Now it's time to start. Hello, let me introduce to you about myself. My name is Young Park, and I'm from Republic of Korea, and I'm a security researcher. Now let's start this session. In this talk, I would like to talk about the Android Packer and how can you unpack the Android application protected by Android Packer generally with your unrooted Android device. First of all, we should know about the Android Packer. There are some papers that explaining features of Android Packers, so we are going to briefly review it. Recently, there are many commercial Android Packers such as Ijami, Banker, DexGuard, and Liep. These Android Packers are similarly working to UPX. UPX is a very simple packer for binary on Windows and Linux. Generally, most of packers are based on execution compression technique. The Android packers are also based on execution compression technique too, and we can distinguish them to two types by main packing mechanism they use. First one is memory patch-based packing, and second one is dynamic code loading-based packing. Now we examine how these two packing mechanisms work. First one is dynamic code loading-based packing. This type of packing loads executable code in file or in memory. And there are some interfaces that is provided by Android platform for loading executable code dynamically. These interfaces are on Java level and on native level. Both on Java level, for example, there are Dex class loader, Test class loader, and Dex file. These interfaces are documented APIs. On the other hand, there are also some undocumented interfaces like method openDexFile in DexFile class. These undocumented interfaces are in form of private method or native function, but we can invoke them through Java reflection and some techniques that are calling unexported functions. Documented interfaces take files as parameter, but as you can see on slide, undocumented interfaces take byte array. It means that we can load executable code on memory dynamically. Usually, it is known that executable code on memory can be loaded because there is no public API for it in Android platform. Apart from interfaces showing in this slide, there are more interfaces can be used for dynamic code loading. This slide shows some functions for dynamic code loading and relations between the functions. On the slide, you can see function names in green, and it represents documented interfaces, and red ones are undocumented interfaces. When you want to use dynamic code loading technique for your Android application, you are usually going to use Path class loader and Dex class loader class on top of the slide. If we see below of the two classes, these classes invoke three functions in green of DexFile class. The three functions in green of the DexFile class are invoking red functions just below of them. As you can see, these functions take two types of parameters. First one is a path of DexFile to load, and the other one is a byte array. So these functions, we can load some code into our running Android application. Functions that load code into memory dynamically are undocumented, but as I mentioned in previous slide, we can call the functions through Java reflection and some techniques calling unexported functions. Now we are going to see how Android packers use the dynamic code loading technique. In this slide, the protected APK file has two files. First one is a classes Dex file for unpacking and loading decrypted Dex file. And the other one is original Dex file. It's encrypted, and it will be decrypted in runtime. When the protected APK is installed and executed, certain class of classes Dex that performs unpacking and loading is executed most firstly. It can be achieved by modifying application tag in Android manifest file. The unpack code executed most firstly can be in form of Java bytecode or ARM machine code by loading additional unpacking module. In this slide, unpacking routine is in unpack SO in native level. Unpack SO loads encrypted Dex file to memory and decrypts it on memory. And then decrypted Dex is stored to temporary file. After that, loader in classes Dex loads the decrypted Dex that is just stored to file temporarily through functions for dynamic code loading, like text class loader and path class loader. And at last, decrypted text file is removed. A lot of Android packers are employing this mechanism. Now, this method is a little different from previous one. A method in previous slide is using temporarily dropped file to load the decrypted text file. But this method loads it in memory directly, not in file. This method works through undocumented interfaces that take byte array as parameter that I mentioned previously. By working like that, it will fix the weakness of a previous method by temporary file. Now, this is packing mechanism based on memory patch. Previous method used the mechanism that loads decrypted text in memory directly. In this method, Android packer encrypts the partial code of original text, so there is no additional loading of text. Two key differences are whether to encrypt all areas or partial areas of the original text, and whether it loads secondary text file dynamically. As you can see on this slide, Android packer firstly modifies the application tag in Android manifest file. By doing so, unpacking SO file can be easily loaded into memory. By unpacking SO, encrypted areas of classes text on memory can be decrypted and executed. And because this method doesn't use secondary text file, it doesn't cause a class load problem that is usually caused by the process system server. I personally think that this type of packing mechanism is the most close implementation of execution compression technique. At this point, we can know the one common weakness of Android packers, that the almost Android packers unpack directly after execution. I actively utilize the weakness to do unpacking. Okay, now I will talk about how to logically unpack these unpacked Android applications. This is a picture we've seen in previous slide. As you can see, that red line box represents the weakness of this packing mechanism. The weakness of this mechanism is that it drops file that has decrypted text, so you can just pick up the dropped file like picking up coin. It's simple. And this method doesn't drop file, and decrypted text is loaded in memory directly. According to the weakness of Android packers we identified, encrypted original text is going to be already decrypted after a main activity appears on the screen of device. Because recent Android packers are unpacking all encrypted code just after execution. Therefore, we can dump it, and that time, it is quite simple. In this case, as I know, and all of you do know, this mechanism also can be simply broken through memory dump. Actually, all packing mechanisms I mentioned before can be broken by memory dump. It is also straightforward. However, it's not simple as we think, because recent Android packers employ various anti-analysis techniques such as anti-debugging, obfuscation, and execution environment detection. So it would be very difficult and time-consuming work to someone on attacker's view like app tracker, and someone on defender's view like a malware analyst. But you can unpack the packed Android applications employing these anti-analysis techniques with my unpacking method. Even it doesn't need a root privilege, so all people who want to unpack with their unrooted device can unpack protected Android application easily. Now let's see how it works. Each one of challenges can be solved through existing anti-analysis techniques. However, real-world packed Android application employs various anti-analysis techniques multiply. That is why we can't analyze the packed Android application fast and easily. So we need to utilize a combination of solutions for these challenges. To analyze the packed application easily, you need to satisfy these conditions. First is that don't use emulator and don't require root privilege. Environment detection techniques such as anti-VM and routing detection has been being advanced consistently, and papers related to these techniques has been released every year. And next, don't use debugger that is based on ptrace and JDWP. JDWP is Java Debug Wired Protocol, and it uses for debugging of Java application. It will be detected by anti-debugging. These things always bother us. If you want to analyze the packed application with the dynamic analysis, maybe you will need the tools like a debugger. But if you simply want to unpack it, you don't surely need the tools like a debugger. Next, applications developed by Java language traditionally utilize code obfuscation against the reverse engineering. And a lot of Android packers protect their unpacking routine through additional packing and obfuscation. So analyzing obfuscated code minutely would be very hard and time-consuming work for an app cracker or malware analyst usually. An item before a last item, pick up, coin, and dump represent a logical unpacking method we've seen in previous slide. It means that we need some method to extract file, to open and dump memory whenever we want. And the last item is about making process environment for unpacking. In my unpacking method, I did it through hooking. This is the key of this unpacking method. This method hooks functions with whatever we want on an unrooted device. All tricks used in this unpacking method are based on hooking. Now, I will talk about how can we hook the functions on unrooted device. In Android platform, there is a feature which I called wait for debug feature. We can debug the Android application through the feature. If the debuggee is set wait for debug flag, it will be waiting for debugger just after execution. In this state, any application's code developed by Android application developer is not executed, and even optimized text file is not loaded yet. If you see memory, you can see that the app's APK file is loaded, but ODEX file in DEX cache directory is not loaded. In that state, if we connect to target application through JDWP, the application will be normally executed and initialized, and then the app's code will be executed finally. At this point, when anti-analysis code of application detects JDWP connection, the packed up application will be terminated incorrectly. To circumvent anti-JDWP, we can just inject our unpacking code into app process that is waiting for debugger through JDWP and detach from it. Code injection technique through JDWP is already well-known technique, so I will not review it in this talk. With this trick, we will not be detected by anti-JDWP, and we didn't use ptrace, so we also will not be detected by anti-ptrace and anti-GDB. And we did unpacking on unrooted device, so we can't be detected by environment detection. By the way, there is one problem. Android manifest file have to be set debuggable flag to enable JDWP in target applications process in Android platform. So we needed to do repackaging the packed Android application we want to analyze. Because of repackaging, we are going to face a problem caused by self-integrity check. However, we can solve this problem through hooking. When we connect to the app that is waiting for debugger through JDWP, we send a request method entry event to the app process. Then, if the app's main thread on Dalvik virtual machine tries to interpret and execute any method, the main thread will be suspended, and we can control execution flow of the main thread. Using control of the main thread, we we can inject our unpacking code into the app process, and it constructs process environment for unpacking through hooking. Even there are no execution flow, we didn't know, because the app process that is waiting for debugger is suspended before finish app process initialization. Therefore, we can inject our unpacking code into the app process through JDWP and detach from it. With this injected unpacking module, everyone who wants to unpack can easily extract the unpacked file or dump memory from the almost 100 packers which have been released at most recently. And so, the title of this session is We Can Still Crack You. And from now, I will talk about how well-known Android packers such as DexGuard and Ijami work. First is the DexGuard. The DexGuard is very powerful Android packer and obfuscator. It's close to protector. So I will focus on only how to unpack it. First of all, you can see some log of LoveCat. This log is generated by DexGuard. In Android platform, when the Android application tries to load the additional text file dynamically, that log is in the slide are generated by Dalvik virtual machine. So we can know whether that the packed up Android application dynamically loads additional text file easily. Class encryption of DexGuard loads two text files dynamically. First one is unpacking code, including class descriptor and the loader. Second one is unpacked text. To extract the unpacked text, I hooked open function in Bionic. Actually, your unpacking method can be different from me because you can hook every function you want, so you can make your own unpacking module with your creative. With my unpacking method, you can just wait until that the unpacked texts are extracted. But in case of DexGuard, despite the extracted text is unpacked, classes in the unpacked text is obfuscated, so we can't analyze code logic well. However, we can anyway extract unpacked text from an Android application packed by DexGuard. Next is Ijami. The Ijami is also well-known Android packer developed by a company in China. Ijami loads additional text directly on memory, so we can't extract the unpacked text through simply hooking an open function. Moreover, it checks integrity of each APK file, so we need to circumvent it. This type of integrity checking is circumvented through that we redirect accessing of repackaged APK file in data app directory to original APK file in data local TMP directory. I copied. By doing so, we can bypass the integrity check routine of Ijami easily. And then we can dump memory because Ijami loads unpacked text on memory directly and it performs dynamic loading through a function dbm text file open partier in LRV dbm module. And the function is exported, so we can easily hook it and extract unpacked text. Liab is also an Android packer. I think it is little known. This packer is developed by a company in Republic of Korea. The Liab also checks its integrity in same way with Ijami, so we can circumvent it in same way with before. And you can extract the unpacked text through hooking an open function because the Liab uses the temporary file to load unpacked text dynamically. Now, now I will demonstrate two well-known Android packers, Banco and APK Protect. First one is Banco. Banco is an Android packer developed by a company in China, and it uses temporary file to load unpacked file, and it employs various anti-analysis techniques such as anti-JDWP, anti-btrace, and emulator detection. Now I'm going to show you how to unpack it. I prepared the sample packed by Banco beforehand. So let me install it first. It is set debuggable, so if I launch this app, it will be terminated incorrectly because it's a self-integrity check. This app after a moment, it is terminated suddenly. It's because a self-integrity check. So let me unpack it. What is the problem? Extension, display extension. Yeah. Okay. Oh, there is some problem. Now, let me unpack it continuously. After installation, now I will unpack it. First, I need to set wait for debug feature set. Yeah. If I launch the app, this app will be waiting for debugger like this, and now I will inject my code into app process. Oh, screen is too small. Yeah, it's done. Now I can unpacking is done. We can extract it. Yeah. As you can see, on the bunker class point text file is unpacked text. So let me extract it and compare it with packed one. Yeah. I will open it with JEB2. First, this is packed one by bunker. Oh, no, no. Uh, as you can see, class list is less, it's small, but if you see unpacked one, you can see all of classes and code. Um, yeah. Let me repackage it with unpacked text. We can repackage it with APK2. Uh, yeah. And replace classes text file with my unpacked one. And just repackage it. And I need to sign it. and I will install it. Yeah, it's success. If I launch the app, this app is unpacked. So we got now completed unpacked APK file, and next is APK Protect. APK Protect patches encrypted code regions of classes DAX image in memory to unpack. APK Protect checks its integrity of optimized DAX image in memory, but we don't modify code in process of repackaging. We just insert a debuggable flag into Android manifest file in APK file. So it's not a problem to us. I will show you. I also prepared the sample protected by APK Protect beforehand. So I need to install it. It this app also is set debuggable, so it will, but it's not terminated because we didn't modify the code, and APK Protect checks its integrity using ODEX image on memory. So we did, this is not problem to us. We can unpack it using memory dump. And I inject my unpacking module. The injection is done, and now we can dump memory. Dump is very simple. Now, in temp directory, there is an unpacked bin file. It's a unpacked text file. So let me extract it and compare it with packed one. Uh, Unpacked bin file we extract is ODEX file. So we needed to do ODEXing. It's very simple things. ODEXing is done, and I will open it with JEB. Uh, this is this is a packed one. So the class list is follow. We see relative code. on create method. JB failed decompilation because the code is encrypted, and we see file code on create method. JB failed disassembly. So, but if we see the unpacked one, yeah, we can see code of method on create. Another class is saying you can see the code of method on receive, but impact one. Oh, you can see you can't see the code. Let's back to the presentation. Now, its conclusion, with this unpacking method, you don't need to analyze unpacked code detailedly. You need just a prediction and tracing through hooking some functions. And I developed a powerful tool that can analyze a complicated and obfuscated code fastly and easily. I will show you when I'm given a chance for it. And now, as you know, we can unpack almost 100 packers with wait for debug feature and function hooking through code injection. And also, I think that companies developing Android packer needs to respond to this technique. So this is the end of my presentation. Thank you. Yeah. Any question? Yeah. Pardon? Oh, yeah. I want to do so, but my company didn't permit it yet. So if my company permit it, I I can do it. I can do it. Release it. Nothing? Yeah. Okay. It's done. And thank you.